Hello everyone, welcome to our channel Codeyantra. So today we will be solving the fourth question, chain reactions of Google Codejam qualification round 2022. So this was a very interesting question. Let's read the problem statement and let's see how to solve this problem. So while lives alone in the desert, so he entertains himself by building some complicated machine that runs on chain reactions. Each machine consists of n modules indexed 1 to n. Each module may point at n one other module with lower index. If not, it point at the abyss. So modules are not pointed at any other are called as initiators. While will can uh, will can manually trigger initiators. When a module is triggered, it triggers the module it is pointing at, if any, which in turn may trigger a third module if it points at one, and so on, until the chain would hit the abyss or an already triggered module. This is called a chain reaction. Each of the n modules has a fun factor Fi. The fun while will gets from a chain reaction is the largest fun factor of all the modules that triggered in that chain reaction. So will is going to trigger each initiator module once in some order. The overall fun will gets from the session is the sum of the fun he gets from each chain reaction. So the question says that we have a tree, okay, and each and that tree is rooted at a abyss, which is some kind of a structure. Here you can say a like a fan like a structure. So this tree is rooted at this, and it is connected to a modules, and the leaf node of the trees are called as initiators. So if you trigger this initiator, it passes on to to the next node, and this passes to the next till the abyss, till we reach the abyss. And if a node is initiated or it is triggered, it can only be triggered once. So if the node is triggered earlier, then after that it cannot be triggered by any other node. So what we have to print that if we what we have to print is if we trigger the initiator in some order, then we will get a fun factor. What is a fun factor? After a nodes get triggered, it has some fun factor. So in a chain reaction, the fun factor of that chain reaction is the maximum fun factor of a node, which we will get is the fun factor of that chain reaction. For example, we can understand this thing using this example. So as we can see that this is a initiator, and this is also an initiator, as this is not connected, and this is only connected to this node and not any other node. So we can see these are directed edges, which is directed upward to the parent of that node. So if I trigger this node first, then it goes here and it also triggers this node, okay, and after reaching here it cannot reach this node, as this node is not directed toward this node, it is directed upwards. So reaching here, the chain reaction stops, and the fun factor we get is that 50, 20 and 60. What is the maximum node, like what is the maximum value we get here from 50, 20 and 60? We get the maximum value as 60. And but this initiator is not triggered yet, so we have to trigger it now. So if I trigger the value 40 here, I will get a chain reaction starting from here, and it will not reach anywhere because this node is already triggered by 50 earlier, so it cannot be triggered again. So this chain reaction stops here, and I get the maximum value as 40, so I get the total value as 100. But let's see one more, like a permutation of this chain reaction. So earlier I started the chain reaction from 50. What if I start the chain reaction here from here? So now if I start the chain reaction from here, it starts here and it goes to 60 and it end at the abyss. So the values I get is 40 and 60. So what is the maximum value? It is 60, and this node cannot be triggered now, this also, and now I have to start from 50 as this was not triggered. So 50 and 20, I get the maximum value as 50. So now I get the answer as 110, which is higher than 100. So 110 will be the answer. So as now as we have understood the question, so now we will be given such a process in which we have to initiate the initiators in some order, and we have to print the maximum answer for every test case. So let's see how to solve this problem. So let's see the first test case. As it says, the range of n is very small, it is 10. So what we can do, we can try out every permutation, that suppose this will be the first initiator after this, and store the answer somewhere, and then try out a different permutation of the initiators and store the answer for them, and in the end we can take the maximum answer. But let's not see that approach, because it will only solve this first test set. It will not solve the second test set and the third. So now let's see the generalized solution here for all the test sets. So now what we will do is let's do some observations. So suppose if I have a node here. Okay, so let's, yeah. So suppose if I have a node here which points which has a value of 1. It has a value, it has 5 children here, 1 2 3 4 and 5. So what I will do, that as a node has 5 branches or 5 children, I can say it will be having 5 like 5 values, which if I suppose I initiate this, it will give me a value. And as the edges are directed upwards, so if I initiate one leaf node or a initiator, other initiators will not get affected, they will not get initiated, right? So if I initiate all of them, I am 100% sure that I will get 5 values from here at this node. So what I can do is I can like store the sum of all these 5 values here, because I'm 100% sure that I will get 5 values from here. So these are 5 and 5 add up to 15 here. Okay, so this node has a summation of has a sum of 5. Now suppose that this is connected to one more node, which is actually 6 here, right? So what I can do is, I know that among all these 5 values, only the initiators, I can actually use this value in one of the chain reactions, right? In only one of the chain reactions. So so what will be the optimal way to take this 6 in one of the chain reaction of the 5 elements? Why I'm saying 5? Because there are only 5 initiators. So if I consider 6 as one of as a like a member of the chain reaction, so which will be the initiator it will be? So as we can see, if we think greedily here, that should be 1, because 1 is the smallest value here. I can replace 1 with 6. So I can keep here 6 instead of 1. And what if I have one more value 7 here? So I can say, if I took the value 6 here, I can replace this 1 with 6, right? We will not be replacing 1 with 6. It is just for just for better visualization of the problem. So what if I taken 7, what if I got 7 here as the parent of 6? So can we say that now the smallest value is 2 here, so I can replace 2 with 7? But actually this is wrong, because the 6 was part of the chain reaction of 1, and now we are saying that we can replace 2 with 7. What does that mean is 7 should be the part of the chain reaction of 2, but we cannot do that because 6 because in the path from 7 to 2, 6 comes in between, and I said that 6 was a part of 1. So it is not possible that 7 is with 2. So what we can do here is I can keep a track of the minimum element here with 15, which is the sum, and from all the children's of this node I can keep the minimum value here, which is 1. And after that, at this node also I can keep the sum value here, which is 15, and the minimum value here. So as you know that this 6 is greater than this minimum value, I can subtract the minimum value from the sum and I can add the current node value here, which will be 20. But now comes the very important part, which is what about the new minimum value? It cannot be 2, it has to be 6, because I just replaced the 1 with 6. Now this thing will go upwards, and I will say that from bottom I got 20 and 6, and I can see the minimum here is smaller than the current node. So I can replace this like 20 minus 6 plus 7, which is 21, and what will be the new minimum? That will be 7, because I just replaced it with the minimum element. So I will do the same thing in the code. So let's see how we will do this thing in code. So let's define a DP array here, a DP vector which will store. So this thing so the DP the DP is a pair of L. So what will this store? This will store the sum, and this will store the minimum element, right? I can say that. So I have made a DP array of n plus 1 size, and I have taken the input like the test case and C for the output, and F array I have made, and I have taken the input here in LL, in long int, and I have initialized the DP array as 0 0 as it contains the garbage value, and I have also taken and I have also made the adjacency list for doing the DFS. So I have made the adjacency list, and I will do, and now I will do the DFS to reach this node, and to like fill the DP array. So uh, like initially what this node will contain, as this was containing 1, it should contain 1, which is the sum, and the minimum value is 1. This contain 2 comma 2, this should contain 3 comma 3, right? So what I will do, I will go here, okay, and if this is the initiator, right, if the adjacency list of that current node doesn't have anything, this means that this is the leaf node, or it can call it a initiator. So what we will say, that if it is initiator, then the sum should contain the value which was f of like that current node, which was given by in the question, right? The value of that node as 60 is here, and that will be f of current node, like 1 comma 1, and same because this will also be the minimum value here, and I will return it. And so like currently initializing it, I will say that as this node, if it comes here, this means that this is not a leaf node, it has to be a parent. So if it comes here, if it if it is 1 and it has 5 children, suppose it has 3 children, right? So I will say that this has to be this, its sum is 0 and its maximum value is 10 raised to 18. Now I will traverse to its children and I will get the sum in this variable and I will store the minimum here. How I will do it? I will traverse on its children's and I will get the pair. What this pair will store? This pair will suppose I have this will return me 1 comma 1 here, right? And this will return me 2 comma 2 here, and this will return me 3 comma 3 here, because the sum of like in this node the sum is 3 and the minimum node is also 3, right? So I will get that in the temp, and I will, and for like this node's dp value is dp of cur, right? So dp of cur dot sum, I will add that in the temp, like I will add this sum variable in the dp cur sum, and I will also update the minimum, that to keep the minimum, that is why I updated, like I initialized the current dp value to 10 raised to 18, and after this I will get the minimum value here, which in this case was 1, and in this case this will also be 1 plus 2 plus 3, which is 6, and the minimum value will be 1. So after I got that, what I can say, that if the current value, uh, like let's take one more example. After this everything will be clear. If suppose this is 7 and this is 1, this is 2, this is 3. So I will get 1 comma 1 here, 2 comma 2 here, and 3 comma 3 here. I will return this to the parent. After, like here I will get the sum, which is 1 plus 2 plus 3 here, which will be 6, and what will be the minimum, which will be 1. Now I will say that the value at this node is actually greater than the minimum node, right? So I can make this 7 a part of a chain reaction of any one of the three initiators, right? So what will that which node will that be, whose 7 will be the part of his chain reaction? So I can say one will be that element, as one is the smallest element among all its children. So now I will say that as 7 is the part of the chain reaction, I can say the answer of that chain reaction should be 7, as this is the maximum value here. So I can say the sum now will be updated to -1, as I am not taking 1, because now this 1 is changed to 7, as 7 is the part of the chain reaction of 1. So so 6 minus 1, because 1 is not, 1 is removed, and 7 will be added here. And what will be the minimum element now? I cannot take the minimum element as 2 and 3, as the chain reaction, as 2 and 3 cannot be a part, cannot extend their chain reaction further, as 1 has extended his chain reaction further, 2 and 3 cannot. So the minimum element will be 7, and the new pair value will be 5 plus 7, which is 12, and the minimum will be 7. So that is why I have done this thing, which is if the current sum, is less than the current node value, then I will reduce the current sum with the minimum value, and I will add the current node value in the sum, and I will also update the minimum with the current node value, and I will return the dp value. After this I will after this all the dp values will be filled, and then I will go back and my answer will be on the dp0 dot f, because this stores the sum, and in the question they told us to find the maximum answer here. So we will print the answer in this format. So I hope you understood all the question. If you have any doubt, you can ask in the comment section. So thank you for watching everyone. I hope you enjoyed and hope you learned something new. So if you like the video, hit the like button and subscribe to our channel. Thank you so much.